Redis began as a caching database, but has since evolved into a primary database. Many applications built today use Redis as a primary database. Unfortunately, most Redis service providers only support Redis as a cache. This means you need a separate database like DynamoDB in addition to using Redis. This adds complexity, latency, and it prevents you from realizing the full potential of Redis. With Redis Enterprise, you can use Redis as both a caching and a primary database in a single system, thus eliminating the complexity and the latency of two separate systems. Not only that, you can also use Redis as a multi-model database. This allows you to build modern applications as well as low latency microservice architectures all on top of Redis. You can also take advantage of native features of Redis Enterprise, such as streams for collecting and distributing data, Redis JSON for storing JSON documents, Redis search for indexing, Redis graph for relationships, Redis time series for application monitoring, Redis Bloom for gaming, fraud detection, and leaderboards, and Redis AI for real-time AI feature store and inferencing. All of this with auto-scaling, enterprise clustering, and active-active geo-replication. Everyone knows Redis began as a caching database, but has since evolved into a primary database. Many applications built today use Redis as a primary database. Unfortunately, most Redis service providers only support Redis as a cache. This means you need a separate database like DynamoDB in addition to using Redis. This adds complexity, latency, and it prevents you from realizing the full potential of Redis. With Redis Enterprise, you can use Redis as both a caching and a primary database in a single system, thus eliminating the complexity and the latency of two separate systems. Not only that, you can also use Redis as a multi-model database. This allows you to build modern applications as well as low latency microservice architectures all on top of Redis. You can also take advantage of native features of Redis Enterprise, such as streams for collecting and distributing data, Redis JSON for storing JSON documents, Redis search for indexing, Redis graph for relationships, Redis time series for application monitoring, Redis Bloom for gaming, fraud detection, and leaderboards, and Redis AI for real-time AI feature store and inferencing. All of this with auto-scaling, enterprise clustering, and active-active geo-replication. Everyone knows Redis began as a caching database, but has since evolved into a primary database. Many applications built today use Redis as a primary database. Unfortunately, most Redis service providers only support Redis as a cache. This means you need a separate database like DynamoDB in addition to using Redis. This adds complexity, latency, and it prevents you from realizing the full potential of Redis. With Redis Enterprise, you can use Redis as both a caching and a primary database in a single system, thus eliminating the complexity and the latency of two separate systems. Not only that, you can also use Redis as a multi-model database. This allows you to build modern applications as well as low latency microservice architectures all on top of Redis. You can also take advantage of native features of Redis Enterprise, such as streams for collecting and distributing data, Redis JSON for storing JSON documents, Redis search for indexing, Redis graph for relationships, Redis time series for application monitoring, Redis Bloom for gaming, fraud detection, and leaderboards, and Redis AI for real-time AI feature store and inferencing. All of this with auto-scaling, enterprise clustering, and active-active geo-replication. Everyone knows Redis began as a cache.
Welcome. We are grateful for your time today. We have an exciting session planned for you in which we are going to show you how simple and easy it is to develop a real-time application with Redis Enterprise and discuss some of the customer use cases and examples. We are hoping that by the end of this session, you are inspired to build a great app that would engage your customers. I am Prasanna Rajgopal. I have spent over 22 years in the software industry in engineering and customer-facing roles at companies such as Oracle and Dell. I have spent the last decade working with customers in a pre-sales role, helping them architect solutions for their various business challenges. I have worked at Redis for the past year and a half. My co-presenter is Suyog Kale, our in-house expert who has 18 years of experience in the software industry. He has extensive experience as a software architect, having worked at various software and product-based companies. He has played a major role in helping banks to certify Redis Enterprise and help in massive migrations from traditional caching solutions like Coherence Gemfire, JVM to Redis Enterprise. He is the author of the book Redis Deep Dive. We also have Sumit Shatwara, who is a solutions architect at Redis, working with BFSI and digital native customers in India. He has over 9 years of experience in the computer software industry, specializing in cloud native and data technologies. He worked with various organizations like Red Hat, NetApp prior to joining Redis. He's here today to help with any technical questions we have in this session. Here's the agenda. We are going to kick off by briefly discussing why financial services are moving to real time. We will highlight why Redis is a key technology to create real time for financial services. We want to prioritize the technical content for you in this webinar. So most of the time you will hear from Suyog. He will explain some of the Redis features in detail and show you a demo. We also have a few inspiring customer stories to share with you today. We want to hear from you. If you have any use cases that you wish to share with us, please let us know on chat. We can unmute you and you can surely share your use cases that you are considering looking at building. Companies are prioritizing digital transformation and increasing the budget to transform their financial services. The biggest reason for this increased focus on digital transformation is that customers expect an easy and fast access to financial services. By digitizing these services, companies are able to scale their services better and acquire customers faster. They are also able to serve their customers at a much lower cost compared to a physical bank or a physical financial center. Thus, financial services company with vast digital operations have much better profits and financial returns. Every single financial services workflow is currently being digitized. You are already aware of the payments revolution in India, Google Pay, UPI, and Paytm. Even the workflow that we as consumers do not see on a day-to-day basis are being transformed, from credit card services to trade services to trading foreign exchange to buying and selling stocks and other securities. Every financial services sector is being transformed. Every business segment, such as corporate, investment banking, consumer community banking, inside a large financial company, has multiple applications that are either being rewritten or created from scratch to make them into real-time services. And Redis is at the center of this revolution. The massive digital transformation opportunity in financial services, such as the need to create highly responsive and personalized experience, the need to scale, and the need to serve millions of customers simultaneously without compromising on performance, and the need to keep the apps available for use by a customer at any time. This is the opportunity that has driven the popularity of Redis. The open source version of Redis is the most downloaded database in the world. By any measure, Redis is a very popular database. Redis has a very engaged community of developers. The product is very easy to get started with. It took me just 2 hours to write a simple app using Redis as the database. I used the Python API to work with the Redis database. As I mentioned earlier, Redis has its roots in open source. The open source version offers simple data structures such as strings and sets that you can use to build a super fast application. Redis Enterprise expands on Redis open source and offers a multi-model support with many features that enterprises need to run their applications in production. Redis Enterprise is built on top of Redis open source database and has all the features of Redis open source, plus offers features such as clustering, linear scalability, finite availability, and more. For example, Redis Enterprise can be deployed in an active-active architecture. This is a data resiliency architecture that distributes the database across multiple data centers via independent and geographically distributed clusters and nodes. Yes, Redis Enterprise offers the reliability and high availability features that companies need. The features that gets me most excited about is the multi-model database support. You can create search indexes on your data using Redis Search and have super fast search feature in your application. If your application needs to store JSON document, we offer Redis JSON as a module. Some of our customers have a need to store and query their data as a graph. Redis Graph offers that feature. If you're creating a brokerage application or a financial application, you need to display maybe stock prices or any other financial data over time. You need a time series database to support such features. And Redis time series can do that for you. In short, you can cover all your application needs using Redis Enterprise. You don't have to use multiple databases in your application and deal with all the complexity that comes with that. I want to share a great customer example. The first example is a large multinational bank based in the US. This long-time Redis customer now uses Redis Enterprise and its multi-model capabilities across various business segments and use cases, including for entitlements, profit and loss reporting, fraud detection, balance forecasting, microservices query caching, session management, rate limiting, and more. This bank recently started using Redis Enterprise to implement an online feature store which enhanced their custom machine learning algorithms to evaluate transaction risk scoring in real time. With Redis, they could access features, score, and derive inferences across millions of accounts, each holding hundreds of transactions with sub-millisecond latency at very high throughput. Speed, scale, and always-on capabilities are three core requirements for this bank, and Redis meets these requirements. This is why they keep expanding their use of Redis. Before I hand this presentation over to Suyog, we are going to do a short poll. After the poll, Suyog will walk you through some of the Redis features and show you his demo. Meanwhile, if you have any comments, any use cases that you wish to discuss, or maybe you're considering right now, we would love to hear from you. So please, at any point in time, let us know via chat, and we would love to hear from you. And here's the first poll. Which domain vertical are you working on? Banks?
Prasanna,
Yes,
Gautam has a question. He just raised his hand. Maybe if you can unmute and let him question.
Yes, sir. Let me stop sharing. Okay.
Yeah, I'll share my screen by that time.
Yeah, I can see your screen. I am unable to unmute him. So wait, let me see.
No problem. So maybe Gautam, if you can put your question in the chat, me or Sumit will answer maybe end of the sessions. Okay. So shall we start?
Oh yeah. So the poll for let's go back to this poll here quickly. Which domain vertical you're working on? Banks. We are seeing a revolution in banks. Which organization? Which role in your organization? Wow, we see a lot of C-level, VP level folks in this. This is developer session, but it's good to have senior folks as well, architects, managers. This is all good to see that great variation in that in the attendees today. So we are grateful. We are truly grateful for your time, and we want to make it worthwhile. So why don't you take over from here and please discuss Redis, please. Thank you, sir.
Thanks, and hi everyone. So I'll talk about little bit covering, because I see there is more people from a developer background, architect people. So I'll just give the high level about the Redis technology as a stack here, right? So if you look at the DB engine, which is very popular in terms of evaluating database technologies, Redis is ranking at say a 6. It's most popular because of few things, right? One is the performance. So everything today is a real time. You need basically almost real time response as a user. And when you basically look at your application implementation, you need databases to respond in a milliseconds time, right? And that's where Redis stands as a first differential factor. The second beauty of Redis is multi-modeling, right? So when you basically think about solving different applications problems, the data structuring is a core component where you want to choose database technology, which gives you flexibility, defining or modeling your data into different format. It could be relational database structures. It could be let's say example time series data structure, graph data structures, searching index. So that way Redis has also basically contributing many applications as a core data modeling component, which gives you basically simple key value pair data structures. And on top of it has basically search index capabilities, streaming capabilities, graph kind of functionalities, JSON, which is basically a document store. So that allows you to applications to solve different problems with better data structuring, right? Basically microservices implementation, where every application's own different ways of solving different problems. And that's where having Redis basically solves your polyglot system, where you don't need to host different databases solving different problems. Maybe Redis can solve many of those use cases, right? This DB engine shows how Redis is ranking here. You can see that mostly the relational databases which are already there in the industry more than decades, those are already ranking high because of their past usage. But Redis is gaining huge popularity today in the community as well as enterprise customer base, right? So as a technology, Redis is an in-memory database. It is implemented as a NoSQL database. So primarily it's a kind of a key value pair database, right? And because it's implemented in a system programming C, these three things contributes Redis as a most performing kind of a databases, right? You can imagine many use cases from gaming, e-commerce, and big data solutions where the millisecond response time is a matter, right? That's where Redis is standing, serving millions of operations per second with sub-millisecond kind of latencies, right? And then there are other attributes which also has in terms of, let's say, a scale, right? Because these categories of NoSQL database, it comes with a horizontal scale, right? Today, relational databases are not able to scale because they are built for your physical servers, meaning that you can only do the vertical scaling, right? You can add more cores and more data sizing in terms of RAM and the disk, but at certain period they will not able to grow when the concurrency is happening to in terms of traffic, right? And that's where the challenge today. So that's where relational data where we are stuck in terms of performance. Versus Redis is a part of NoSQL databases, so it comes with the horizontal scaling, right? And it not beyond only the horizontal scale, but also allowing you to deploy Redis geographically, right? Most of our customers today use Redis deploying either active or active passive into one or multiple data centers. That gives you not only better in terms of availability point of view, but also distributing the local traffic to the local nearest data center, right? Which is also another classic example why Redis Enterprise point of view is very popular in the production level of deployments. As I mentioned, the performance is the first thing, and multi-modeling is another important where Redis is standing a first choice of developers. So these things are basically helping. for developers and architects. And I have seen most of the core architectures that, in terms of monetization, digitalizations, where you are adapting modern technologies like microservices, streaming services, and NoSQL kind of a databases. Redis is becoming core part of technology. Redis was started 10 years back, mostly as a caching technologies, because by beauty of a key value pair, right? Whatever the static data you can think about, which is frequently in reserve, Redis was primarily as used as a key value pair and the caching technologies, right? But because today it's coming with enterprise grade, where the security and high ability is out of box there, and certain unique enterprise features, which is basically kind of deploying active passive, Redis on flash, and a lot of other enterprise features makes Redis as a robust technology using as a primary store as well. Now, I'm not going to do kind of a labs here today because we have just limited time. So I'll just touch the high level data structures, and then we can definitely have other sessions more deep dive, right? So Redis is a key value pair by design. So what does that mean? Every entity that you're storing has a unique name, and then there is a value associated. Now, when I say key value pair, it doesn't mean only it's a string type of, there are multiple types in a key value pair kind of a thing, right? So these are the types of key value pairs Redis has. So example, string. So example, any caching use cases you think about, you can store as a string, right? So example, let's say all your master configurations, error codes, or let's say the website which is serving data, or any API caching that you're probably caching, you can use a string data structure, right? There is a bitmap, bit fields, and these are the cognitive data structures. Think about, you want to just click the counters, or maybe you just want to, cognitive values. Like example, I just want to know how many unique users has visited my website, which product or which portfolio they have visited. So if you just want to categorize those, I can use bit fields and bitmaps, right? Hash is the next version of string, which allows you to basically store multiple fields and values. Common example is profiles and catalog values, right? Example, you just creating session object for your mobile banking applications, and rather than storing in the relational database, we can simply use the Redis to store the user session in the using especially the hash data structure, right? It can be simply your auth tokens and maybe additional information that might be associated to that particular session objects, right? List is a kind of again very it's a common data structure in terms of adjacent queue, right? Where you have more members in the list, and that you want to probably process into the queue manner, maybe as a stack data tree or first FIFO kind of a technology, right? So where you have Redis command in terms of performing, read and write from both the sides, right? Sets, sorted sets are again basically a kind of a list data structure, but it allows you to store uniqueness, meaning that if you want to store unique members into the Redis, maybe example, I just want to know all unique users who has performed their KYC, right? Or maybe, I want to basically categorize user based on the cities, right? Or maybe the people who has not submitted their address book, those kind of use cases, right? I can store them, right? So geospatial data index is another classic data structure. Today, most of the applications for banking is moving towards the mobiles, right? Supporting mobile platforms. So that way, location services are very popular today. Think about, based on the user location, you just want to perform, simple rule, the fraud analysis. Maybe this yoga is based out of Maharashtra, but there is a transition happening in some outside, maybe India. So there is a high chances of the fraud, right? So based on the location, you can easily do. There is a lot of proactive use cases for serving the better functionalities to the user. Let's say somebody is at airport and probably they providing the travel insurance based use case for that user, right? Maybe he has forgot to get the travel insurance, so you can easily give that, based on that location on his mobile banking application, right? Hyperlog is a kind of again a probability data structure. Think about certain use cases. Let's say there is a black IP addresses which are restricted for transaction, or certain other activities might have robotics activities, right? So those kind of activities that you have logged into the probability data structure. So whenever there's a new transaction happening, you can easily figure it out. There's a chances of this is the bad IP request, or maybe bot bot that is already recognized. Streaming is another popular data structure. Any use cases where there's a microservices implementation and you need massive communication between one or another, notification implementations or in transit data processing. So you can use a streaming technology, which is a persistent queue inside Redis, right? So there is this all basic data structures help you to solve different problems, and we can definitely help you, what kind of use case you might be solving and what could be the right way of using these data structures. Okay, we'll go quickly on this data structure in detail. So string is basically simple key value pair. There are certain types of command that we give performing those set and get operations, right? Now, by the way, this increment and decrement is also a classic example. Let's say for UPI payment you want to perform some kind of account balance, right? Or maybe example for UPI, now you want to do some kind of a metering implementation. So based on user daily transaction, every bank is coming with a daily limits, or maybe for new accounts there is a certain transaction amount limit, right? So you can easily manage those unique keys, and because Redis is a key value pair, whether there are 10,000 users or 10 million users, you can easily store those across multiple shards and probably get the same millisecond type of response, right? So string is a very classic example apart from the caching use cases, right? Hash, which is a very similar to string, but it allows you to store multiple fields against one key, right? Session management is a classic example. And because it allows you to fetch partial values, maybe example from that object, you just want to put pull the token attribute. So you just pass the key name and perform the that particular field to perform, right? So edge-get is basically kind of a select star in the relational databases, right? And you can perform edge-get for selecting, say a particular attribute and to page, right? List is a kind of adjacent list, right? Which is allowing you to push. So there is a L push, R push kind of operations to perform, and you can add multiple elements to that, right? It's a job queue or task processing, which is a classic example where the list is very popular, right? And there is you can perform either LPOP or put basically fetch the single record, or RPOP, which is from the right. So L and R is basically starting, which is a left or right, that operation you want to perform. And there are range queries as well. So if you want to fetch 10 items at a time, or you want to fetch all the items at a time, so you can perform the range queries either left or right side. Set, which talked about unique items, and it also has a certain capabilities performing intersects, union. So example, you might be storing all the users who has pending address proof, or maybe all the users who has pending KYC. And now you also want to know who is the user who has not performed KYC and not performed the address or not submitted the mobile. So maybe there might be different unique sets, and then you can internally perform unions and joins, depends on the criteria that you want to perform your business logic, right? Sorted set is a similar to set, but it also gives adding some scores. So example, let's say you have some kind of a leaderboard for the users, and maybe on the trading solution, who is more active user, you might want to give him some more points, right? So something like that you can basically build on this using sorted set. In the gaming, sorted sets is very popular because you just want to build a leaderboard for the gaming applications, right? For particular game product, or maybe for a particular team into the game, right? So fantasy applications mostly use sorted set as a classic example, right? Think about the KBC, which is a very popular TV show in the India, right? Which actually also has a lot of leaderboard, and they have almost 3 to 4 million insertions between 2-3 milliseconds, and that's where Redis was a classic example, solving that high throughput kind of a scenario, just single sorted set kind of a use case, right? Publish subscriber is again another example where you think about broadcasting or messaging implementation. It could be your let's say some task activity, some transaction has happened, and you want some other applications to notice. Maybe there is one application listening to this message for product analysis. Some application might be just kind of a customer 360 where they want to, or third application might be generating SMS for that user, right? So there can be other application listening to a single event, and they might be doing their own activities in parallel. So publish subscriber is a classic example. It can be also has a logo, subscriber based on the regular expression. So not necessarily all the messages that you are publishing you want to listen. So you might, want to filter based on your regular expression. Additional to this publish subscriber, we also have this stream data structure, which difference is basically the publish subscriber is a kind of a fire and forget. So the message that you are broadcasting, the consumer is not available, you will lose the message, but the streaming is giving you the persistent, right? So depends on the, millions of publish events are happening to that stream, the consumer might be slow, or might be a group of consumer who might be processing that data, right? So this is something you can see. So mostly the in-transit data processing, I have seen the streaming is very popular, right? It could be a transaction processing, it could be analytical data processing, or data pipelines. The streaming was very popular data structure, and you can relate other message brokers like RabbitMQ, Kafka, or other keyings that things. I have seen that streaming, Redis stream has been gaining a huge popularity there as well, right? We talked about basic data structure, but on top of that, we have also built the modules which gives you better capabilities for other capabilities like search index, right? So we have Redis search example where you have a lot of data and you also want to perform secondary indexes, right? So example, I have customer data, but now I want to fetch customer, not only the customer ID, but maybe also based on the mobile number and the condition, maybe that that user has performed the KYC or not, right? Or maybe other attributes, let's say example, Aadhaar card number, or maybe some government IDs, unique identification, or maybe their status on their account activations, all right? So there could be combinations, and also maybe you also want to do the paging, you want to do aggregations, right? So those kind of examples you can build on the Redis search. Now, Redis is coming with the JSON data structure, which is again helping you to store multi-level of JSON objects, right? Think about, you have probably portfolios for the product, or maybe let's example, the customer and that has accounts. So maybe you have some account in JSON object inside a particular user, right? So that way the JSON store is a very popular. We have time series and we have gears and other attributes like AI and probability data structure, which allow you to do a lot of things inside Redis, right? And that's where the microservices implementation today, very classic example for all the model implementation that we do today. And you have different use cases to solve different data structuring, right? Where the data modeling can be very different. You can't really use relational databases in all the scenarios because it will be not a right solution in terms of performance and scale, right? And that's where, because Redis is a multi-model and it's a faster database, it is very popular, solving different problems in this kind of a journey, right? So we'll start with another poll and then we'll have demo. By that time, I'll stop my screen because I just preparing my demo. Okay.
Okay, Suyog, thank you so much for that great introduction about Redis. Guys, please keep your questions coming. While you answer this, please keep your questions coming. We would love to hear from you. We are here for you. It's not about us, it's about you. So please keep those questions coming. Sumit has just answered one of the questions, which was a great question, by the way. And Sumit answered it really well. Thank you, Sumit. Thank you so much for helping us out with the session. So please keep those coming. We want to hear from you. We are here for you. We want to help you. In this poll, we are asking this question: what would you like to use Redis for? Caching? Yeah, that's everybody uses. That's a great use case. Searching, yeah, searching. We are seeing that search is a great use case. Redis search indexing is just really good. Redis search might be a good use case for good product for that. Session management, yeah, that's also very popular. Document store, Redis JSON might be a good option for that. Leaderboards, we have a lot of gaming customers worldwide, and obviously they use Redis for leaderboards, so it's a very obvious use case there. Machine learning, it's growing in popularity in machine learning, in really real-time decision making and automation, where machine learning is used during the decision-making workflow. Redis is used as a feature store. Like I spoke to you about that customer in the US who's using for risk scoring of transactions, using their machine learning model, and they're using Redis as a feature store. So thank you for answering that question. We also had a second question: which cloud do you use? On-premise. Yes, on-premise is not going anywhere, guys. Not in banking. There's so many applications that are on-premise. It's going to take maybe 2-3 decades to transform them and then move it completely to the cloud. And it's also expensive. We want to protect margins. We want to protect profit margins. Nobody's got infinite amount of money. So becomes on-premise is going to be with us. AWS, obviously, they are the leaders in this. So GCP, Azure, IBM's there. That's good to see them there. And then which database do you use? Oracle. Yes, Oracle has been there for a long time. And like Suyog mentioned, they are the entrenched players. They are there. Legacy applications are all been built on Oracle. MySQL, Postgres, MongoDB is very popular. We understand that. Cassandra too. It's good to see that it's the diversity in these responses is really good to see. So thank you for all this. And Suyog, whenever you're ready, you can take it away. So
just 1 second, guys.
Yeah, please take your time. No rush. And yeah, please keep those questions coming, and we'd love to hear from you. And hear about your use cases and the challenges that you're facing. And we like to learn from you, and you can learn from us. We have experts like Suyog and Sumit on this call today just for you. So make use of us.
Yes, so I'm sharing my screen. So the demo is basically, showing how that I can improve my relational databases performance. So we are not really helping you to, re-architect your relational databases, but using Redis in front of any query coming to the relational databases, right? So idea is basically we have Redis connectors, which allows you to sync data from these relational databases into the Redis, and then you can have applications to perform queries on the Redis databases, right? The bigger problem here is I have other applications which are updating or inserting new data into the relational databases. How I can make sure that my data into the Redis is correct and accurate in terms of the real-time traffic, right? So Redis connector is basically available for syncing data from multiple relational databases, file systems, and Kafka kind of use cases. So you can use this connector. This will allow you to basically do the initial data load into the Redis as well as the real time. So meaning that, let's example, I have Oracle and I'm basically using this Redis Connect to my pushing data into the Redis. And then you'll have to configure specific databases, specific tables. In the columns, maybe I have only interest into, let's say, few columns that I want to sync into Redis, and then Redis has a ability to sync into the hash data structure, which is we have seen multiple fields values which represent a row from your relational databases, right? So example, I have use case where transactional data, right? So today transactional data, which is very important in terms of serving the traffic, and there are many use cases, right? So example, let's say take a payment transaction information. Maybe it is a UPI, or maybe just a normal transaction that you normally see in the mobile banking. As a user, when I log in, I want to see my transaction history, right? But there are a lot of other use cases that that you have to serve for the that data, right? Which is a historical data, but there's a lot of traffic is coming. But imagine if that data is there and there are millions of record in your relational databases. There's unnecessary traffic coming to that Oracle or whatever the relational database you're using, and that cause the impact, the performance for other primary use cases that you are serving from the relational databases, right? Simply, what you can do, you can probably move, let's example, let us 1 month data or 3 month data into the Redis, and then serve that data from there so that you can reduce down the traffic from relational databases. Also, when you're serving from that data into Redis or from the Redis, it can be served in the millisecond time, right? And there are many use cases, like example, your mobile banking, net banking, which showing recent transaction, or user is basically trying to fetch between 2 dates or type of transaction, you can easily serve from Redis, right? Then again, there is a statement generation. Somebody is asking statement for XYZ reason, or maybe there's a monthly statement that you're generating and sending, or promotional campaign. So based on the user transaction, you might want to do some kind of analytical logic to generate some kind of a promotion campaign for that user, maybe example credit card discount offer, or maybe EMI offer kind of things, right? Or maybe the product analysis, right? You processing that data and generating some kind of product analysis for your further real-time inference queries. So this has many advantages serving these use cases at real time, but because today this is a relation in the relational database becomes informative. So we have customer who has moved this. By the way, this is one example, but there are different types of tables and different types of data that you have where this can be use case. So now the challenge for this, how I can bring this data into the Redis at real time and without much development at my application side, right? So you can use Redis connector, and that's what we are targeting demo here. Imagine you have data into your relational database, and now you want to bring that data into Redis at real time whenever there's changes or updates are happening, and that's what we are trying to show here. So this is how the Redis connector architecture is. So it basically allows you to configure your specific database as a source. So there are a set of databases today we support for this kind of a Redis connect, and then certain log miners, or basically it's basically not impacting your source database. So it doesn't mean that when you use Redis connect, it's going to create additional traffic to your database. No. So it's going to use the transaction logs from the source database. So normally, example, Oracle has a Golden Gate, or it also has a log miner support. So once you enable that logging, the CDC Redis connect will only depends on that and not going to generate the traffic. So there is no impacting on the performance, right? And then we use Debizium as a CDC here, change data capture mechanism, which will listen those log changes, and then respect to your tables that you have configured, it will generate stream into your Redis connect. Redis stream is basically the data structure we talked, which is a queuing dot changes for the tables. And likely if there are 10 tables, 100 tables, there might be 10 different streams, 100 different streams to the target Redis connector, right? And then it will basically have its own internal eventing to update those respective records. Now, today we support hash and JSON at a target data structure into the Redis. And on top of that, you can perform indexing to perform this kind of queries, right? So that's how the high level architecture is. I'm going to show you this demo. So let me bring my demo here. Give me just a second. So this is my source database. I have used here MySQL MariaDB, right? So example, right now I'm just simply having just dummy database. And in that, I have right now transaction table, right? Which has basically certain attributes based on user activities in terms of debits and credits, right? So this is my table right now, which has some records based on the timestamp. And my goal is basically get this data at real time into the Redis so that I can really solve that queries in a millisecond type of response time. So what I will do here is basically right now I have basically just running this my connector here, which is showing me the status, and there are a lot of attributes we have basically added apart from this basic matrix you see here. So as I mentioned that I have configured my whole database into Redis connector. So whatever the change is happening, all those table, there is a kind of a streaming already configured into this connector. So it basically represent your database and tables as a queue. So when there is a real-time traffic is going to come, it will start queuing there, and this Redis will basically push into the target database, right? So my Debizium is already running behind the scene, and what I will do basically, I will use my Node.js code, which is going to generate some dummy traffic, right? So by the way, Redis is basically is just going to put that record as a hash. So if I go my this ID interface for browsing Redis data, so this is something like that record is representing here, right? So this is my relational database data structure. So you're performing select star for particular account and order by that particular transaction date, maybe just 5 records that I want to see here. And if I go here in the Redis, I can see that already there are some data already there, right? Which I just created in the morning. So it represents some hash data structure here in the Redis. And then maybe based on the transaction ID, I can just get the hgetall command and get the transaction. Or maybe if I want to now, let's say for that specific user, I want to get the data. So maybe I can just perform indexing on these documents. So these are nothing but now transaction documents inside Redis. And maybe I can apply index. So Redis in search is allowing me to index on specific attributes. So not all the attributes, let's example, transaction ID transaction date, or maybe the account ID I want to, index. So I'll create index one time, and then maybe I can just perform. So this is nothing but, search query. This is the format of, how you're performing the search queries on the this indexed document. So I'm just passing my index and star, which is a very similar what might be you do in a select star from that table in the relational database, right? So you just like can see that around 84,000 records are there. And let's say I just want to fetch for particular account, maybe top 5 records, right? And again, further here, I can say that show me only specific related attribute and not all, right? So this is something I will show you for that account, latest records order by this transaction date, right? So right now I'm just refreshing because there is no data coming, so there is no change. So you can see that right now there is a 2 expenses that particular or credits are done again the particular, this particular activity, right, for that particular account ID. Now what I will do, I will push some traffic performing my this script. So which is simply, generating some insert into that table into my MySQL database, right? So you can see that I'm just performing insert command into that transaction against that specific account and the timestamp and doing some, dummy credit and debit kind of operations, right? So if I go here in my MySQL, you can see that if I perform this query, I'm getting some change in my that account, right? So obviously right now here there's a less record, but imagine if I have millions of record, this query will degrade, right, in terms of performance. And if there is a concurrency of, let's say, example, 1,000, 10,000 queries happening to that table in a same time, it will almost start, degrading seconds time, like maybe 5 seconds, 6 seconds, at times more than 2 seconds, right? Now, if I go to Redis here and I start to, just refresh, you can see that I see basically, getting the latest record for that. So it's actually happening real time. So whatever the insert I'm doing into my that relational databases, those are getting synced into the Redis, and now I can perform those kind of search queries at real time. Now we do have customers who are doing this kind of implementations in the production scale, and they have almost 10,000, 12,000 queries at real time with the sub-millisecond latency, almost like 5 millisecond, even those kind of a concurrency, right? So this is the demo, and now we'll go on the next poll. I'll just stop my sharing.
Okay. Thank you, Suyog. So we have one more poll before we switch into a few more couple of customer stories. There have been a lot of good questions on the chat. Thank you so much for that. We would love to hear more from you. So what in this poll, we are asking you the question of what peak traffic do your applications normally serve? Less than 5,000 transactions per second. Some of you are doing nearly more than 1 million transactions a second, close to 100,000 transactions a second. So that's really good. What type of database does your application use? RDBMS, documents, graph, time series, key value search? Great responses, guys. Thank you so much. We are really grateful. And let's move into the, we have 15 more minutes left. So let's quickly move into the customer stories. Yeah, so consumers across the globe, let me put this in full screen mode. Consumers across the globe have wholeheartedly adapted digital wallets and payment apps. They use these apps to pay for all their expenses. You are well aware of the revolution in payments in India. Nowadays, when consumers send payments to someone, we expect instantaneous delivery and settlement of that payment. We cannot stand delays anymore. Now the business to business payments has joined this revolution too, and business to business is even more vast because businesses have many suppliers and many suppliers have many other suppliers. The whole supply chain has to be funded across the globe. You can imagine the complexity of paying all those people. Many businesses manage a vast number of suppliers and make numerous purchases to run their businesses each day. With real-time B2B payments, they are able to simplify the end-to-end process of managing purchase orders and invoices. These companies have better control of their cash and a real-time view of their cash positions globally. And they are able to better manage their liquidity. Just imagine a multinational company having thousands of suppliers across the globe, having to pay them, having to manage all that, and having to automate the workflow. If they can automate the entire workflow and prevent fraud, prevent the risk, then they can better manage their cash, they can reduce the working capital, and thus have better financial returns. It's all about financial returns in the end. How can we make a more profitable company? That is an excellent presentation on YouTube from our Redis conference by the architect of the new payment system at Capital One. You can watch it by scanning the QR code on this slide. Capital One is an American bank founded 28 years ago. It now operates 100% in the cloud. The bank's customers have embraced mobile banking and expect a real-time customer experience. They are also the 5th largest payment processor in the US. Processing over 1.5 billion payments across their consumer and commercial line of businesses. That payments team led by Mike Lee was looking to scale their payments application and make those services work in real time. They leverage a streaming, event-driven microservices architecture throughout their businesses. They use Redis Enterprise as the database for many of their microservices. Suyog actually talked about this, how Redis can be used for microservices, and for caching of microservices data. A real-time architecture allowed them to assess the status of every payment in real time. Suyog, you have helped architect payment solutions for bank in Asia. Can you share some of your thoughts?
Yeah, so there are multiple use cases where the real-time data use cases was a challenge. So example, in-transit data processing, right? So where when you perform a transaction, you have a lot of things to do, right? You have to authenticate the user, you have to authorize, you have to basically check the account balance, and there is a lot of activities that you do between your relational database or basically your other data sources, maybe 10 to 12 different operations, and that has a lot of challenges when it comes to the concurrency. Imagine the payment traffic is growing everywhere, including, like example, in the India, we have UPI, right? So this UPI also has basically also handshake certain, let's example, NPCI, when you do basically the VP authentication, or you basically want to do the data asset data processing. And again, when the transaction is processing, you also have metering, right? So example, there is in a UPI, we have, like example, daily limits for that particular user to perform transaction, or for new user, there is a per transaction limit. So those kind of activities you have to do. And again, there is a lot of transaction scoring, right? Whether this is a fraud. So you can't really do all those things at the scale and at such a concurrency with relational databases, right? And that's the beauty of microservices. When there is a transaction is happening, you have multiple microservices. They are going to do their jobs and come to the community that, okay, this is what we should be doing, right? So this microservices help to do those activities in parallel. But when it comes to the relational databases traffic serving, right, it's not that easy with the, when you use the network, all a lot of network factors and all those comes where. And that's where we work with a Redis technology stack in those kind of solutions. The beauty was because Redis is a key value pair, horizontal scale, it was easy to, game the data processing. So for microservices, we use streaming for the message communication between the applications. We use certain data processing inside stream. We use, like example, certain configurations that frequently need to process, whether it is a common configuration across the applications. For example, let's say the daily limit configurations, right? Example, maybe for user, there is a certain already transaction happen every day. So you can actually keep those records for that user. And again, Redis provides expiry or basically anything but time to leave in the Redis. You can basically do that at a Redis level. Second thing is the other problems, the traditional caching solutions the banks are using, maybe it is a coherence, JVM, in-memory caching, like a chain file. that has a lot of problems and they cannot really work with these modern technologies, right? The scale and in fact, the capabilities that we want a multi-modeling, it's not possible. And because Redis has this all enterprise feature, think about, I want to go active, I want to go active, passive, I want to support multiple regions, and I might have hybrid. Maybe I have some setup running in my, let's say public cloud, like AWS and GCP, and I have still certain load running on premises, right? All these features, if you want to solve today at today's real-time demand, you will have to take 5 years to go back and do that development. And that features sets are already coming with the enterprise. So that's what we are doing today.
Thank you, Suyog. Thank you so much. And it's so great to watch this payments revolution, because it is changing lives, it is changing businesses, changing the way we do things, and making it more efficient and profitable for everybody involved in that payments ecosystem. So the next here is our next example. Ekata helps prevent fraud. It primarily sells its services to e-commerce, financial services, and payments companies to automate the process of onboarding new vendors onto a platform or help customers open new accounts. Ekata verifies the authenticity of businesses and people by using identity graph built on Redis Enterprise. Their goal is to reduce friction in verifying financial transactions while at the same time keeping their infrastructure costs low. Ekata has built a massive database of 5 billion keys with Redis Enterprise. Their previous in-memory solution was too expensive to operate for their scale. Ekata settled on Redis on Flash for their deployment on AWS. You can read the story, Ekata story, by scanning that QR code as well. It's on redis.com website. Ekata is a great example of how Redis helped this company achieve their business goals with Redis solutions. These two quotes from the SVP of engineering, Varun, summarizes how Redis directly addressed their business goals. Ekata has a sub-100 millisecond latency requirement, according to Varun Kumar. Redis on Flash reduced their RAM usage, thus saving them money while meeting their strict latency requirements. You have ideas in you that you can implement today. You can try out Redis for free and implement your use case using various features and see which features would meet your customers' requirements. You can get a $200 in cloud credits when you sign up. We are in this unique moment in history. We have this once in a lifetime opportunity to make a difference in this world. Let's make full use of this opportunity in front of us. There can be so many ideas within us that can still be tried that will make a difference in your customer's life. So please try this out, make use of this opportunity. There are various ways in which Redis is contributing back to the developer community. You can access all these resources to further your knowledge and understanding of Redis and the various use cases. And here are more resources that you can use. You can use the QR code to scan it and learn more about Redis and also about the various use cases as well. We are open to any questions. I believe we still have some time left, about a minute or so. How much time do we have left right now? Trying to see. So we have about 4 more minutes left. So is there any more questions, Sumit? Have you seen any more questions come up?
So Praveen is asking if you can share the recording and the slides for them to refer later.
I believe we will be sharing the recording and the slides, I guess. But we can surely, I think, share a PDF version of the slides, as I think.
I think Anurag has a lot of questions. Anurag, if you like to unmute yourself and if you want some clarity on some of the answers which we have provided, we are happy to do that.
Yeah, no, for sure. So Anurag, his final question: when Redis Enterprise is installed on on-premise infrastructure, it will maintain backup as well. That was his question. Yes, we have persistence. Suyog answered it by saying that we have persistence, backup, and restore features in Redis. And Sumit has also shared a link to the durable Redis documentation. And I mean, that is, I like this question from Anurag. As you mentioned, Redis is single-threaded, how it manages parallel requests. Let's say there are 10,000 clients using application at the same time. That's the beauty of Redis. It's just so beautifully well designed, I would say. And
Yeah,
but
can
Sumit
I
has given
answer that question, Prasanna?
Pardon me, sir?
Yeah, can I answer this question?
Yes, please. Yes, please go ahead, sir.
So for audience, the question is how Redis manage the concurrency and if there are a lot of traffic because Redis is a single threaded. So Redis comes with the sharding capabilities, meaning that it's partition data into the multiple shards. Every shard is allocating its core and CPU cores and the memory, right? What does that mean? If I have 10 million user records as a session, it's example. It will be get distributed on the allocated shards, and then in front of this all shard, the Redis Enterprise has a proxy service which actually manages connections. This proxy is actually multi-threaded and it can manage thousands of connections. We have customer who has, let's say, example, 100,000 connections to a Redis database, right? And then the proxy is internally, distributing this traffic to the respective key based on where it is sitting. So you don't need to worry as your application implementation, how I should manage this scale. And in fact, it allows you to do this real-time sharding. Let's example, you're using Redis Enterprise on AWS from the marketplace as a managed service. Let's say you have today, you have 10,000 TPS serving, and probably because there is a festival coming, maybe you're expecting that is going to be 100,000. You just put the throughput for your database in the in the configuration or the REST API, make it, let's example, 100,000. Internally, Redis will automatically provision those required sharding. So it's basically nothing but doing the horizontal sharding for your data, and then you'll able to serve that 100,000 TPS with millisecond time of response, right? So this all the scaling and distribution is taken care of by enterprise out of this.
Thank you, Suyog. That was a great answer. Thank you so much for that detailed explanation. I hope that adds some color. Sumit has also, I think, shared a few resources on that topic. So please do review those videos and any documentation. Feel free to reach out to us. And after this event, we can also share via email our contact information. We'd love to hear from you as much as, we love to hear as much as you can. Send us more questions, any use cases that you are considering. We'd love to hear all of that. So we are very grateful for your time today. We are almost out of time.
Yeah, Alok has one question like which
Sure.
Redis Java client you recommend to connect Redis DB? Yeah, so there is a multiple client available. Normally we have Redis and Redis as a very commonly used, almost like a 50-50%. We as an organization also heavily contribute into the Redis client library. So depends on your use cases. Redis is more recommended because it comes with pipeline features as well. So, and again, support for this example, there is a OEM libraries that we have recently introduced for Redis and Redis, which allows you to perform Redis search queries more as object modeling, right? So that way you can also use the sub libraries for search, JSON store kind of use cases. I hope that answers your question, Alok.
Thank you, Suyog. Hey, can we please include some of the links for the topics that you just talked about? Maybe the links to the library documentation, please, Suyog.
Yeah.
In the post event, maybe email.
Sure.
Thank you, sir. Thank you. Appreciate. We want to share as much knowledge as we can with our audience.
So the developer.redis.com website, actually, we have a lot of examples. So you'll able to select Java, Node.js, and there is the examples respect to the different client libraries. So I will just share that. That may be easy to,
That's developer.redis.com.
Yeah.
Okay.
I'm sharing that link on the chart.
That's amazing. If there are no more questions, we are going to close this session out, and you will get an email from us. We are truly grateful for your time today, and let's keep this conversation going. We are here to help you. So, and I would also like to thank Suyog for his great demo, and Sumit for taking the time to answer those questions patiently. And thank you so much for your time. Thank you, guys. Hope to see you back soon. Thank you so much.